electrolysis. Look today, Kolbes Electrolysis. So what is a Kolbes electrolysis? In Kolbe electrolysis, we have first of all a container over which we have one positive charge and one we have a negative charge. Here we have on left hand side we have anode, on right hand side we have cathode. Now alkenes are formed by, how does electrolysis form alkene? So alkanes are formed by electrolysis of concentrated aqueous solution of sodium or potassium salt of saturated monocarboxylic acid. So how does this reaction takes place? This reaction, first of all, we have let's say 2 moles of RC double bond ONA, or we have RC double bond OH, that is reacting with A with NaOH, and B we have electrolysis. So first of all, we gonna react acid with NaOH. Acid and base form a salt, O minus Na plus. And on electrolysis, if we electrolysis the salt, cathode part goes on, cation goes on cathode side and anion goes on anode side. So in anode side we get R plus 2 CO2, that we get on anode side, and on cathode side we get NaOH react with H2, that we get on cathode side. Example, we have 2C2H5 COONA. If we electrolyze this, electrolysis, then it forms C2H5 plus 2CO2 plus 2NaOH plus H2, in which we know what is our cathode product and what is our anode product. What is the mechanism behind it? What mechanism do we follow? First of all, let's talk on anode, which is a positively charged species. Anode is a positively charged here. So on anode, anion goes. We have seen in electrochemistry that on electrolysis of anode, anion goes there. So C2H5, C double bond O negative. When it loses electron, it forms C2H5, C double bond O free radical. It forms C double bond O free radical. Now that C2H5, C double bond O free radical, that fragmentation, and C2H5 is here. How it fragment? It breaks the bond. It breaks the bond here like this, and it forms a C2H5, C double bond O. There is no free radical. C2H5, C double bond O free radical. And after fragmentation, yes, there is a free radical. After fragmentation, it forms C2H5, C double bond O, and C2H5 free radical plus CO2. Now more than one free radical C2H5 reacts with C2H5 free radical and forms CH3, CH2. then CH2 and CH3. It forms the product. But as we know that it is 2 degree, it is a 1 degree, so it forms a minor product also, which is our disproportionation product. We have CH3 hydrogen, CH2 hydrogen, we have CH2 free radical, which react with C2H5 free radical, and it forms CH3 CH2H plus CH2 double bond CH2, which is a minor product. So disproportionation reaction takes place. It goes here and hydrogen goes up, so it forms a minor product. And what we observe at cathode, hydrogen will take electron and it will get reduced to H2 and in basic medium. And what is the drawback of the reaction? We know the points we need to know about this reaction. First, methane cannot be formed by this method. We cannot form methane. Second, electrolysis of an acid salt gives symmetrical alkane. It gives us symmetrical alkane. Now in case of mixture, when we have more mixture of salt acids are when we have a salt of mixture, all possible alkanes are formed. How all possible alkanes are formed? Let's say we have a RCOOH plus R-COOH, which on electrolysis form R-R- plus R plus RR plus 2CO2 plus H2 plus NaOH. All the possible product we will be getting over here. Next point, we need to know that the presence of alkyl groups in alpha position decreases the yield of alkanes. It decreases the yield of alkanes, and it is actually a free radical mechanism. So presence of alkyl group in alpha position decreases the yield of alkane. So whenever we have alpha position alkyl group, it will decrease the yield of alkane, and it will move to form the disproportionation product. And when we have fifth point, anode, we have alkane, which is a major product, plus CO2, and cathode we have NaOH plus H2. 6 DOH minus by dt is greater than 0, or concentration of OH minus decreases with time at cathode or solution.